Hello guys, this is Miss Hanley here, and we're going to talk about notes number 4, which corresponds with assignment 4, and that's talking about graphing linear functions. So again, you should have these notes in your packet, so flip to that page and fill them in as we go. Okay, so within this assignment, you are going to be doing two things. You're going to be graphing linear functions in slope-intercept form, and you're going to be graphing them in standard form. So this is the first worksheet that you have where you're graphing linear functions in slope-intercept form. And let's do number 1 together. So they're giving you a slope and a y-intercept. And so you want to build the equation. And the easiest equation to graph is y equals mx plus b, which, as you know, that's your slope-intercept form. So when I want to create this equation, y and x are going to stay as part of my equation. My slope is 1/4, and my y-intercept is -2. So I'm just going to write that instead of plus -2 as -2. Okay, so this tells me, and let me make my marker a little bigger here, okay, that I want to start at -2 on my y-intercept. So I'm going down to the y-axis at -2 and making my first point. Excuse me. Since my slope is positive, I should see an increasing line. And so remember, we're always looking for rise over run. So from there, I'm going to go up 1 and up 1. Hold on one second. We're going to go up 1 and over 1, 2, 3, 4. And so my new point is going to be at 4, -1. Now, we want to continue this line. We want at least 3 points before we draw a line. But I can't actually go up 1 and to the right 4 anymore. So instead, I'm going to start back at -2. And I'm going to go down 1 and to the left 1, 2, 3, 4. And so that's going to be my new point at -4, -3. And now that you have those, you can connect your line. And you always want arrows at both ends because that tells you it's a continuous function and that line keeps going. So let's talk for a second about the different types of lines that you might run into. One of those is a line with a slope of 0. Well, a slope of 0 means that there is just no slope, so that's a flat line. If you think about it in terms of maybe you're a skier or snowboarder, if you're on something with a slope of 0, you're not really moving, right? You're just sort of staying there. So that's when, that's when your line is horizontal, when you have a slope of 0. Like you're, at the base of the mountain next to the lodge, you're not going anywhere, you have to skate to go anywhere, so you're at a slope of 0. The opposite of that would be if you're a really adventurous skier and you're jumping off a cliff and you're going straight down and there's no snow underneath you. Well, that slope is undefined, right? That's a pretty radical skiing. When you're going straight up and down, that slope is totally undefined. If you just have a negative slope, so in the last example we had a positive 1/4 slope and we increased our line. If we have a negative slope, our line should start tall on the left and decrease to the right, so we would say it's falling. And if it's a positive slope, it starts low on the left and increases on the right, so it is an increasing positive slope there. Okay, so now we're going to talk about how to graph those lines when they're in standard form. So remember, standard form of a linear equation is ax plus by is equal to c. You do have your shortcuts to find slope, right? You have -a over b is your slope, and your y-intercept is c divided by b. So you can certainly use those to help you graph. Here, however, we're going to look at taking an equation in standard form and changing it into slope-intercept form, and using the graphing just the way we did a minute ago. or finding our x and y intercept and graphing that way. So the first method is to change it into slope-intercept form. The second method is going to be to find the x and y intercept. So let's take one equation and we're going to solve it both ways. Okay, so our equation that we're going to work with here is negative 2x plus 5y is equal to 10. Okay, and this is number 1 on your worksheet, the second side of your worksheet here. So the first step that we have is to, remember, if we're changing it into slope-intercept form, we have to move ax, right? So we're going to start with negative 2x plus 5y is equal to 10. Oops. And I'm going to add 2x to both sides. So I end up with 5y equals 2x plus 10. So since those aren't like terms, I can't actually combine them. And then the second step is going to be divide by b, right? So our b in this case is 5, and we have to divide, oh, I'm sorry. I'm going to use the actual number 5 here. We're going to divide each piece by the b value, which is 5. So we end up with y is equal to 2/5 x plus, and 10 divided by 5 is 2, right? So now we can start graphing that. So here we get two different things. We have a point, we have a y-intercept, which is a point, and we have a slope. So if we start with this y-intercept, we always start at b. B is where you begin, and that's at positive 2. Alright, and then our slope tells us that we need to move up 2 and over 1, 2, 3, 4, 5. So up 2 over 5 would put me right there. Alright, and in that same respect, we could go from the y-intercept down 2 and to the left, 1, 2, 3, 4, 5. So going up 2 and over 5 to the right 5 is the same as going down 2 and to the left 5. And that's because that second movement is negative 2 over negative 5, which is really a positive value, right? So there you get the graph of your line, and you did it by changing from standard form into slope-intercept form. And that's probably the way I do it most often. However, there's always method 2, which is finding your x and y intercept. Okay, so for our second method, we're first going to find the x-intercept. So we want to take our standard form equation, and when you're finding an x-intercept, when you're on the x-axis here, every time you're on the x-axis, the y value is 0 because you haven't gone up and you haven't gone down. So when I'm doing this, I'm technically going to cover up the piece that I don't want. But what really is happening is I'm substituting in 0 for the y value. So if I want to find the x-intercept, I'm replacing y with 0, which gives me negative 2x is equal to 10, and that tells me that x is negative 5. So my x-intercept is 1, 2, 3, 4, 5, is the point negative 5, 0. And we can see that from our previous graph that that's exactly where we landed on there. Now, if we want to find the y-intercept, we're going to substitute in 0 for x. And so now we have, well, negative 2 times 0 is 0. So we have 5y is equal to 10, or y is equal to 2. And so if I go over to my y-intercept, I know that I have a point at 2, which again, you can see we have that point on our first graph, and we have the -5 on our first graph. So now once I have an x and y intercept, I can graph that line. We have the same exact line as we do on the left. We just found it in a different way. So you can choose whichever method you would like to when you're doing assignment 4.